Okay, we're going to look at local maxima and minima, so maximum points and minimum points on a curve. And we start by drawing the graph of a function. So I just want a coordinate grid here, like this. And let's mark off some points. 1, 2, 3, 1, 2, 3. And 1, 2, 3, 1, 2, 3, and then we have -1 here, and we have -1 here. Okay, so we want to draw the function f of x equal minus x squared plus 2x plus 2. And we can set up a value table for that function to plot the most important points. So we have x and f of x. If x is 0, what happens to the function? Well, the function value will be 2. If x is 1, we have -1 plus 2 plus 2, that's going to be 3. If x is 2, we have -4 plus 4 plus 2, so that's going to be 2. If x is 3, -9 plus 6 plus 2, that's -1. And if x is -1, we're going to have -1 plus 2, sorry, -2 plus 2, so that's going to be -1 as well. Okay, so we can plot these points. We have a point here, we have a point here, we have a point here, we also have a point here, and we have a point here. Is that all of them? Let's see. 1, 2, 3, 4, 5. Yeah. So we can well, let's draw the curve here. Now, ideally, we should have more points to get an accurate curve of this function. So 5 points would be too few. But now we want to examine some tangents for this function. This one and oops, terrible. This one and this one. So these are all tangents because they touch the graph of the function at a single point. So these are the tangents at x equals 0. So that's this one here. The point where the tangent touches the curve, it has the coordinates 0 and 2. And we notice that the tangent is positive. Or sorry, the not the tangent, but the gradient. Gradient is positive. The gradient is positive. If we examine another point where x is equal to 2, that's here. So we've looked at these two. The coordinates for that point is 2, 2. And we can establish that the gradient of the tangent in that point is negative because the line is sloping downwards. And the final example, at this point where x is equal to 1, this is the point with coordinates 1 and 3, we notice that the gradient is 0. 0. Now, we can also notice that this is the maximum point on the curve, on the parabola, because this point marks the maximum value for the function, which is 3. It's also called a turning point because this is where the curve turns. And turning points are often of great interest to us. And how do we find them? Well, the gradient of the tangent is always 0 at turning points. So we simply set the gradient function to 0. That's what we're going to do. So our original function that was f of x equal minus x squared plus 2x plus 2. And we want to find the gradient function. So the derivative of this function is going to be, okay, 2 multiplied with minus 1, so that's minus 2x. And we reduce the power with a factor of 1, or just with 1. And the next term, we differentiate 2x, that's going to be 2. And the last term is going to be 0, so we can just do that. So this is the gradient function, and we set the gradient function equal to 0. Minus 2x plus 2 is equal to 0. Okay, we subtract 2 from each side. So we get minus 2x equals minus 2. We can then divide by minus 2 on each side. And x is equal to 1. Okay, so now we have the solution to that. So we set the gradient function equal to 0, and we got the answer x equals 1. And that's the x-coordinate of the point that we want. We also want the y-coordinate, so we can put it into the original function. F of 1 is equal to minus 1 squared plus 2 times 1 plus 2, which is this is minus 1 plus 2 plus 2, so that's going to be 3. And we have our answer. The turning point is 1, 3. So this point has the coordinates 1, 3. And the reason why it's a turning point, again, we find the gradient function. We can set the gradient function equal to 0 because the gradient at the maximum is 0. And it works the same for minimum points. Yeah, so if we have a parabola going the other way around, again, we're going to have different tangents at different points, but at the minimum point, we have a tangent with a gradient of 0. So set the gradient function equal to 0, and we find that minimum or maximum point.